So challenge 3, this is the optional, this is the flip side of challenge 3. Again, I didn't fit it all into this section because I don't know if I could. I may have been able to, but I just wanted more room. So this problem, basically the outline is that there are 3 charged balls hanging from strings, and they're in a perfect equilateral triangle with a distance of 20 centimeters or 0.2 meters between each ball, and they weigh 0.003 kilograms, and this length here is 80 centimeters. So basically my first inclination was, oh, you can just set up a force balance equation that, because there's not that many forces acting on the balls, there's just Fg, force of gravity, and then a tension force, and then a force outwards. That's, I call it the force electric, or the repulsive force of the 2 other balls on one ball. So basically what you can do is you can find this force here using the x component of the tension force, because you know force of gravity, and once you have this, what did I call it? I think Ftx or something for the x component of the tension force. But once you find that, you basically know the amount of force that's pushing in this direction, the force electric, which of the electric field. So you can use that to find Q, which I'll do at the end. So you can use geometry to find exactly where in this triangle this goes through, and then this distance here, which is, I'll call it x. Oh, I did call it x. Great. So this triangle is 20, 20, 20. It's an equilateral, perfect equilateral triangle, and this length here is 2x, and this length here is x, because this is a perfect altitude of the triangle, and you find that this length is 2 root 300 over 3, or 2/3 of the square root of 300. And you know that this is a right angle, you know this side, and you know that side, so you can find this angle theta, and it turns out that, using cos inverse, and it turns out that that is 81.7 degrees. So then you can set up the force balance of, because now you know the perfect dimensions of this triangle, and going down is just mg, because it's just mass times gravity, is the y aspect, the y component of the tension force. Fty is basically just equal to mg, and Ftx is equal to the electric force, or the force generated by the electric field that's pushing outwards against the ball in the x direction. So yeah, Ftx is equal to kqqq over r squared, and Ft, I think this says Fty, equal to mg tan theta, and we know theta from the previous page. So basically, we just kind of manipulate these and say mg over tan theta, which is the y component, is equal to 2kqqq sine of 60 over r squared, to find, this 2 is because there are 2 balls instead of one single ball. And they're pushing in the x direction. So basically all we have to do at this point is solve for q. So mg divided by tan theta times r squared is equal to 2k q squared sine 60. Q, then q squared, but basically all I have to do is solve for q. So you have mg over tan theta r squared divided by 2k sine 60, and then you take the square root of that. And once you have this expression, all you have to do is plug in numbers, which I did down here in pencil, because sometimes I make mistakes and it's just easier to work in pencil when you're dealing with this many numbers. So the final result I got as 4.0574 times 10 to the negative 8th coulombs, and that would be the charge Q on each ball. And remember that each ball has the same equal charge Q. And this is what I got.